Okay, today we discuss two problems, two important problems. Um, let's just start. Consider the following statements in respect of square matrices A, B, C, each of same order n. The first statement is if AB equals to AC implies B equal to C if A is non-singular. This is the first statement, and the second statement if Bx equals to Cx for every column matrix X having n rows, then B equal to C. So we have to state which of the statements is or are correct. Okay. Now see the first statement. It is given that AB equals to AC. Does always AB equal to AC implies B equal to C? Let's just check this. Okay. Now see that it is given A is non-singular. What does it means? It means that determinant of A not equal to 0. Determinant of A not equals to 0. So we can calculate the A inverse. A inverse equals to 1 by determinant of A into adjoint of A. So it is A inverse. Now see that the inverse has a property that A into A inverse or A inverse into A both gives us the identity matrix. This is the property of inverse matrix. Okay. Now see that if AB equals to AC, we can pre-multiply A inverse with both sides. Okay. Now as the matrix multiplication is associative, we can write this A inverse A into C. Now if since A inverse A equals to I, we can write it down like this. In into B equals to In into C. Moreover, we know that this identity matrix acts like a one in our natural numbers, because if we multiply anything with this matrix, it gives us the same matrix. So In into B is B itself, and In into C is C itself. So if AB equals to AC, then B equal to C. It only holds if A is non-singular, because if A is non-singular, we can pre-multiply with A inverse. Similarly, it holds for the this also. If BA equal to CA, then we multiply each side from A with A inverse from the right side, and we get B equal to C. So the first statement is correct. Now come to the second statement. If Bx equals to Cx for every column matrix X having n rows, then B equal to C. We now check this statement. Okay. So it is given that Bx equal to Cx for every column matrix X, that is n cross 1. N cross 1 is a column matrix, and we write it like x1, x2 up to xn. It is an n cross n matrix which contains n rows and one column. Okay. Suppose we write it down like this: B, B11, B12, B1n, B21, B22, B2n, Bn1, Bn2, Bnn, and C equal to the same like C11, C12, C1n, C21, C22, C2n, and Cn1, Cn2, Cnn, as both are n cross n matrix. So we let B and C like this. Now the interesting thing is it this holds for every column matrix. Okay, so what if we choose this matrix x1, suppose 1, and the first one is 1 and all the other term are 0. So for this x1 also bx1 equal to cx1. Now the thing is that if I multiply this, bx1 equals to cx1. Okay, so we just write it down, b11, b1n. I'm writing it shortly so that the calculation would be easier. 1 0 0 up to n times 0 equals to the same cx, that is cx1, that is c11 cn, sorry, 1n cn1 cnn, 1 0 0 up to n. So what if we multiply this? We get a it is a n cross n matrix. It is a n cross 1 matrix. So we get a n cross 1 matrix. That is a column. We get a column. And what column it gives? B11, this row into this column. So B11 into 1, B12 into 0, B13 into 0, and so on. So all the terms are 0 except B11. So for the first row, we get B11. Now come to the second row. B12, sorry, B21, B22 up to B2n and 10000. So B21 into 1 and all the terms are zeros. So we get B21. For the third row and first column, we get B31 and so on, Bn1. We get this from the left hand side, and for the right hand side also we get C11, C21 up to Cn1. So see that it is the first column of B and it is the first column of C. So the first column of B, we can see that if we take x1, then we can state that the first column of B is equal to the first column of C. Okay. Similarly, if we take suppose x1 equals to, sorry, x2 equals to, the first one is 0, the second one is 1, and the rest are 0. So we get if B, it also holds because x2 is a column matrix and it satisfies for every column matrix. So we get the second column of B, that is B12, B22, Bn2 equal to, we get the second column C12, C22, Cn2. So second column of B is equal to second column of C. And considering this way, we consider xn equals to 0, 0 up. The last one is n. So we get the nth column of B equals to nth column of C. So we can state that all the columns of all the columns of B is step by step equals to all the columns of C. So if all the columns are same, if of all the corresponding columns are same, then we can state that B equal to C. So if this holds, so if this holds, Bx equal to Cx for every column matrix X, then we can say that B equal to C. So this statement 2 is also correct. So we get back to the question. Which of the given above is or are correct? Both 1 and 2. Both 1 and 2 are correct. Okay, now move to the next question. This one, question 5. It is given that consider the following statement. Uh, Factorial 25 plus 1 is divisible by 26, and factorial 6 plus 1 is divisible by 7. Which of the statements are correct? So it is, don't panic for this. After seeing this question, it is not at all a tough question, but we have to think for a while. Okay, first we take the number, suppose n equals to factorial 25 plus 1, whether it is divisible by 26 or not. Okay, if we can be able to write this as 26 into k, 26 into k for some k, then we can say that yes, it is 20, it is divisible by 26 because we get a factor 26 here. Obviously k need to be an integer. Okay, so we just try to find out. Now see that in n it is 25 factorial plus 1. Now we can see that in 25 factorial, 25 factorial means 1, 2, up to there exists a 13 in between, 14 and 25 plus 1. Okay, so see that we can get a 2 and 13 here, multiplication. So we can write like 26 into some k1 plus 1, where k1 equals to 1, sorry, 2 is out, 1, 3, 11, 12, 14, up to 25. It is a great integer. It is a huge integer, positive integer. That doesn't matter. We can consider it as a k. So n can be written as 26 k1 plus 1. And see that we cannot take common out of this. So if n equals to 26 k1 plus 1, so we can state that if we divide 26 to n, we can always get a remainder 1. Okay, so so this n is not actually divisible by 26. So the first statement is wrong. Similarly, uh, suppose m equals to, we consider the second statement. Let's add a slide. So take m equals to factorial 6 plus 1. Okay, so see that for factorial 6, there these are the numbers plus 1, and for divisibility of 7, actually 7 is a prime number, right? 7 is a prime number, so it will be divisible by 7 if there exists a term, if we can be able to write it like 7k or something. Okay, but 6 factorial is given. So now we use, actually there is a great theorem, Wilson theorem. It actually helps us in this solving this problem, and it states that if p is prime, then p divides p minus 1 factorial p minus 1 plus 1. It is a theorem of Wilson. So we can see that here n is 7. So 7 minus 1 factorial 7 minus 1 plus 1, actually 7 divides this. So 7 divides 6 factorial plus 1. We can state that. Moreover, we can calculate it like 6 factorial. We know that is 720 plus 1, that is 721. And we can see that 7, it can be written as 7 into 103 or something. Yes, 103. So we can find out that it comes from the observation. Okay, but what if we get a bigger number? Suppose it is like 12 factorial 12 plus 1, whether it is divisible by 13 or not. Is it divisible by 13? Suppose it has been asked. So what we will do, we'll check the Wilson theorem. If this number is prime, yes, it is a prime number. So p minus factorial p minus 1 plus 1 is divisible by 13. So the statement is here, 2 is true. So 1 is false, 2 is true. So the correct option is 2 only. Which of the statement is are correct? 2 only. So these are the two solutions, and stay tuned for more. Thank you.